All right, we're looking at systems of equations. You've done some of this in your secondary math 1 classes, so your freshman year or 9th grade year. We're going to do a quick review, just remind you that you are very comfortable with graphing lines, even though it's been a while. So let's take a look at this number 1. This equation is written in slope-intercept form, where the constant that doesn't have a variable with it is your y-intercept, and the m, the coefficient of the variable x, that is your slope. So to graph this, to graph a line when it's in slope-intercept form is quite easy. The y-intercept in this case is 1, so I'm going to identify 1 on the y-axis, the vertical line. And from there, I'm going to rise 3/5, but this is negative. So typically on a slope, the top number is telling you to go up, the bottom number is telling you how much to run to the right. If you've got a negative, you're going to apply that either to the numerator or denominator. So let me show you what I mean. On this first one, I'm going to apply it to the numerator. So instead of going up 3, I'm going to rise down 3. 1, 2, 3, and then go to the right 5. If I did that again, I would be off the grid, so I want to go the opposite direction. So I'm back to my y-intercept, looking at that spot once more. From here, I'm going to rise positive 3, but then I'm going to run to the left, so I'm using the negative this time on the denominator, right? And if I've done this correctly, I should have a negative slope, meaning as I looked from left to right, the line should be going down, okay? So it's a negative slope because that coefficient was negative. So that's just a few reminders there. Let's do one. This one is not in slope-intercept form. This is in, it's actually standard form. As I solved these with students, you can graph this by finding the y-intercept and the x-intercept, but our x-intercept is, they're fractions all over the place on this. So what I would like for you to do instead is solve this so that it's in slope-intercept form. In other words, solve it for y. So for this equation, we could start by subtracting 3x from both sides. Right, so that would look like, I'm going to rewrite it over here, 2y equals negative 8 minus 3x. And then to get y alone, we'll divide every term by 2. So we get y equals negative 4 minus 3/2 x. Dividing each term is going to allow us to see a clear picture of what is the y-intercept, in this case negative 4, and it also separates the slope. So we have a slope of negative 3/2. If I go down 3 and right 2, I'm off the grid. So I'm just going to go ahead and go the opposite direction. I'm going to rise positive 3, but then run negative 2, left 2. And I'll do it again. Up 3, left 2, and once more. 1, 2, 3, 1, 2. So I've got myself a line right there. Okay, this should all feel like review. Should be pretty comfortable to you. So we are going to move on to, let's try problem 9. Now we have two equations, so we're going to graph both of them and identify where they intersect. So if I graph the top one, I'll go ahead and use green for that. I'm going to go down 3, my y-intercept is negative 3, and then the slope for this one is negative 5. Now to change that to a fraction, I can simply put a 1 under it. If I use the negative with the numerator, that would mean rise down 5, and that would be off the grid. So I'm going to instead use it with the denominator. So I'm going to rise up 5 and left 1. And I could do it again, I'd be off the grid. So I'm just going to go ahead and connect these. Oh, that was, I'm going to do my best to draw a straight line. It's not easy to do on this app, in my opinion, but okay, last try. We're just going to say that's close enough. All right, let's graph this next one. This equation, it has a y-intercept of 1, and then its slope appears to be missing, just negative. So remember that if in front of a variable there is no number written, if the coefficient seems to be missing, it's really a 1. So we're going to use this as a slope of negative 1 over 1. So I'm going to rise down 1, then right 1, down 1, right 1. And then to go the opposite direction, I'm going to rise up 1 and then left 1. I'm going to use the negative on the denominator now. Okay, and we can see that these 2 points intersect. They do cross at that spot right there. And we're going to name that point. That's our solution to this equation, or to this system of equations, excuse me. This is at -1, 2. The first number in the ordered pair is telling us how far left to right to go, and the second number is telling us up or down. Okay, x and then y. Alphabetical order, if that helps. X first, then y. Okay, so one thing that I want you to do is that when you get the solution, I want you to check in each equation and make sure that it really works. So let's take a look at this top one. If I replace the x with -1, I would get 5 minus 3, which equals 2, and that fits. That answers what we thought it would, because we said that y is 2. If I replace the x here with -1, then we'd have 1 plus 1, that's 2, so it works as well. Got them both. Okay, so that's the general idea behind graphing. There's a few more example problems for you to try that are already in slope-intercept form. Number 12 is a little bit unique because we have an equation that is y equals 3. So regardless of whatever x value we choose, y is 3. So if I say, okay, what if x is 3? Y is still 3 there. What if x is 0? Y is 3. What if x is -5? Is still 3. So we've got this line, a constant line at y equals 3. Okay, to graph the second equation, we're going to need to do a little bit of algebra, and let's get it into slope-intercept form. So I want to solve for y. I'm going to subtract 4x from both sides. Then I have 3y equals -3 minus 4x. Divide every term by 3. And we get y equals -1 minus 4/3 x. So now our y-intercept is -1, and our slope, we're going to rise 4, run 3. If I rise down 4, 1, 2, 3, 4, and right 3, I get that point right there. Let's go the opposite direction. So back to our intercept. I'm going to rise in the positive direction 4, and then left 3. And again, we have an intersection. So there is the answer. It's going to be at -3, 3. We could plug this into check. That would be -12 plus 9. -12 plus 9 is -3, so that one works. And of course, y equals 3. They gave us that, so yep, that one works as well. Let's try, well, let me describe a situation for you. So suppose that you're graphing a couple of lines, and they look like this. This would occur if the slope was the same. So they both have a slope. We'll say that it's of 3/4 or something like that. If they both have the same slope but a different y-intercept, crossing the y-axis at a different place, then these will never intersect. So this is a no solution situation. We would never have an answer there. Okay. We could also have a situation, unique one, where we have one line, and then when you go to graph the other line, it's right on top of it. So this means that we have infinitely many solutions. Wow, spell that correctly. Infinitely many solutions. Yeah. All right. Maybe let's do this last one. We'll do 18. Okay, so I want to solve each equation for y. Let's start with the top one. I'll subtract x from both sides. So we get 2 minus x equals 2y. Then divide every single term by 2. So I'd get 1 minus 1/2 x equals y. Now my y-intercept is 1. My slope is -1/2. So I'm going to go rise down 1 and then right 2. Down 1, right 2. And let's go the opposite direction. Up 1, left 2. Up 1, left 2. There's one of our lines. Let's solve the other equation for y and see what we get here. So let's see, I'll add 2x to both sides. So that will look like 2x minus 4 equals negative 4y. And then let's divide every single term by 4. That would be negative 1/2 x plus 1 equals y. Well, there's the situation we were just talking about, isn't it? There's our y-intercept. If I go down 1 and right 2, look at this. We have an identical line. So this one fits the infinitely many solutions scenario. Okay, there were 6 homework problems associated with this one. 11-1, those are attached here in Canvas as well, and I think you should be able to have success with that.